A very good morning, students. Today, I'm going to handle class on manufacturing engineering under the scheme of AICTE PRERANA. This scheme is especially for preparing SC/ST students for higher education, especially GATE. And as I said before, today's topic will be manufacturing engineering. And myself, N.S.MOHAN, Assistant Professor, working for the Department of Mechanical Engineering in Erode Sengunthar Engineering College. Okay, today we are going to see some previously asked GATE questions on the topic of manufacturing engineering. Okay, you will be getting around 20 to 30 marks from this particular topic in GATE questions. Okay, and it is very easy for you to score more than 20 marks out of 30 in this particular topic. Okay, today I have about 30 questions along with some answers also. Okay, let us discuss the questions and then we will go to the answers. And I'll be giving the explanation for the same. Okay. So here is your first question. The first question is, in abrasive jet machining, as the distance between the nozzle tip and the work surface increases, the material removal rate. Okay. The question is, when the distance between the nozzle tip and the work surface, when it gets increased, what will be the metal removal rate? They are asking what will be the MRR rate, right? So, okay. So first option is given as it increases continuously. The second option is it decreases continuously. Option C is it decreases, becomes stable, and then increases. It means that it first decreases, then it becomes stable, and then after reaching a particular point, it again increases. That is your third option. And finally, fourth option comes like this: it increases, becomes stable at a point, and then it decreases. Okay, this was the question which was asked in the year 2012, and this particular question carries 1 mark. Okay, so what would be the answer? Can anyone tell me the answer? Okay, let us see the answers now. So the first, for the first question, the answer is option D. Let us see what is option D. So it says that it increases, it becomes stable, and then finally it gets decreased. Okay, the explanation is here. Okay, so looking on to this particular graph, the graph is drawn between the distance between the workpiece and the nozzle tip. The graph has been drawn here. Okay, so it means that it is clear from the graph that the material removal rate is first increases. Okay, as the distance between the nozzle and the workpiece is minimum, it increases. First it gets increased, then it becomes stable. It becomes stable for a particular point. Here you can find that at a particular point it has become stable and then it getting decreased. Okay, so it means that when the nozzle moves away from the workpiece, when the nozzle moves away from the workpiece, the MRR rate will not increase. The MRR rate will get reduced. So the velocity of the jet, okay, either it may be a water jet machining or an abrasive jet machining, the velocity should be more. Okay, when you maintain the distance between the nozzle and the workpiece as minimum, the velocity will be more, and that in turn helps in better MRR rate, metal removal rate. Okay, so please note it down. So the option is just note the question and then write the answers alone. So no need to note down all these points. Okay, just write the answers alone. The option is D. It increases, then it becomes stable, and then finally it decreases. That's your answer. Okay, so let us move on to the next question. Okay, the second question is the hardness of the grain. Okay, let me say which year they have asked this question. It is from the year of 2002, and this question also carries 1 mark. Okay, this question also carries 1 mark. Okay, let us see the question now. The hardness of the grinding wheel is determined by. Okay, the question is what determines the hardness of the grinding wheel? Okay, so let us see what are the options they have given. So the first option is hardness of the abrasive grains, the ability of the bond to retain abrasive grains. The third option is hardness of the bond. Okay, hardness of the bond. And the fourth option is ability of the grinding wheel to penetrate the workpiece. Okay, the ability of the grinding wheel to penetrate the workpiece. Okay, let us see the meaning. Hardness of the abrasive grains is whatever may be the grains you are abrasive grains you are selecting, it should be hard. Okay, whether that is determining the hardness of the grinding wheel. Okay, that is the first option. The second option is ability of the bond to retain abrasive. Okay, so we are choosing abrasive grains first, and then what type of bond you are using. So, yeah, what type of bond you are using for bonding the grains together. So, yeah, what is the type of bond you are using to what to say using to bind the abrasive grains together. Okay, that is your second point. Then third point is hardness of the bond. Yeah, hardness of the bond will, I think it won't be the answer. It won't be the right thing because the bond hardness will never determine the hardness of the grinding wheel. Okay. So next, the last point is ability of the grinding wheel to penetrate the workpiece. Okay, it means that what they are saying is the abrasive grain should penetrate the workpiece. Okay, if it gets penetrated into the workpiece, there is no possibility for it to machine. Okay, machining is not possible. So it should not get penetrated completely. But instead, what it should do is it should just rub the surface of the material to remove the material. Okay. Okay, let us see the answer now. So the correct option is answer B. Okay, let us see the explanation now. Each abrasive grain usually removes only a very small amount of material at a time. Okay, so abrasive grains, we have n number of abrasive grains in a grinding wheel, right? So only a particular part will get what to say will come in contact with the material. Okay, that particular abrasive grain will only remove the material. Okay, that is the point. Then what they are saying is high rates of material removal can be achieved only if large number of grains act together. Okay, so it is very important. Okay, it is to be noted that large amount of grains has to come in contact with the material. Okay, that is the second point. This is done by using bonded adhesives. Yeah. So adhesives is nothing but the ability to bind the material together. So yeah, here we are using we are using abrasive grains. So these abrasive grains has to be binded together. Okay, so only it will produce a better output. Okay. The next point is given as the abrasive grains are held together by a bonding material. Yeah, by a bonding material which acts as a supporting force or braces between the grains. It is a supporting medium. The bond is a supporting medium which helps to hold two or more abrasive grains together. Okay, and it also increases the hardness of the grinding. So the answer is option B. Okay, so it is very clear that high MRR is attained only if bonding of the abrasive grains is good. Okay, if the bonding is not good, either the grinding wheel will break, or it will get collapsed, or it will get the abrasive grains may lose its bondability. It won't get well bonded with other abrasive grains. Okay, so the bonding material should be of high quality and it should be of high bondability. It should have a high adhesive property. The bonding material should have a high adhesive property. Okay, so let us move on to the third question now. So third question is a match the following question. It's a type of match the following question. And this question is asked in the year of 2012 and it also carries 1 mark. Okay. So let us see the question now. Match the following metal forming processes with their associated stress in the workpiece. Okay. It means that we have some 4 types of metal forming processes. So in each metal forming processes, what is the type of stresses they are experiencing? Okay, what is the type of stress the material is experiencing? Okay, right. So let us see the options now. So we have metal forming processes. We have first process of coining. Coining is the process of compressing the material and creating an object. Okay, so next is wire drawing. Wire drawing is also some type of compressive load will be acting. Then blanking. Then at the last they have given deep drawing process. Okay. So on the right hand side, they have given types of stresses. So what types of stresses mean? The first point comes as tensile stress. The second, shear stress. The third option is tensile and compressive stress. Both tensile and compressive stress is acting. Then the last option is compressive stress alone. Okay. So they have given option as first option is for coining they have given they have matched with compressive. Okay. The second point is to wire drawing they have paired it with tensile stress. Then third blanking they have paired with shear stress, and move on to the next option they have given us for coining they have given us compressive stress. Then for wire drawing they have given us tensile stress. For blanking they have given us tensile and compressive stress. And for redrawing they have paired it with shear stress. Okay. Uh, Next is option C. Coining is paired with tensile stress. Then wire drawing is matched with shear stress. Blanking is matched with compressive stress. And finally, deep drawing is matched with tensile and compressive stress. Okay. This is the third option. And finally, we are going to the fourth option. Coining is paired with tensile stress. Then wire drawing is paired with tensile and compressive stress. Next, blanking is compared with shear stress, and finally deep drawing is paired with compressive stress. Okay. So let us see what is the correct option. So option A is the correct answer. Okay. So option A comes as for metal forming process, coining process, we are using compressive stress. Then for wire drawing process, we are using the material is experiencing a tensile stress. Then third option, blanking, it is experiencing shear stress. And finally, deep drawing, it is experiencing both tensile and as well as compressive stress. Okay, so please make a note. So the question is as the following. They have given some metal forming process on the right hand side and types of stresses on the left hand side. So the option is option 1. Okay, option A is the correct answer. Right. So next, let us move on to the next question. That is the fourth question. So fourth question comes like this. It is asked in the year 2012 and it also carries 1 mark. During normalizing process of steel, the specimen is heated. Okay. In what temperature, in what range it is heated? That is the question. And we have options as option A, between the upper and the lower critical temperature, and cooled air is still, and cooled air, cooled in still air. Okay, cooled in still air is nothing but room temperature. Okay, right. So next option is option B, above the upper critical temperature and cooled in furnace. Okay. We have a cooling furnace over here. So next option C is above the upper critical temperature and cooled in still air. Still air is again, it means that it is getting cooled in what? Room temperature. Right. Okay. Next, coming to the fourth option, between the upper and the lower critical temperature and cooled in furnace. Okay. They have said that it is not reaching its upper critical point and it is not reaching its lower critical point. It is just between upper critical and lower critical temperature, and finally it is cooled in furnace, they are saying. Okay. So first we have to know about what is normalizing process. Yeah. So normalizing process is nothing but normalizing involves heating of metal. Okay. It involves heating of material to an elevated temperature. To an elevated temperature is nothing but upper critical temperature. Right. So it is the maximum point that the metal will get converted into liquid. Yeah. Okay. So up to that level, the material is getting heated and allowing it to cool in a room temperature. Yeah. Allowing it to cool down in room temperature. That is what normalizing is all about. Okay. So what will be the answer now? The answer will be option C. Okay. So option C comes like this. As I already explained, they have given what is normalizing means. Okay. Normalizing involves prolonged heating just above the critical temperature to produce globular form of carbide and then cooling an air. Okay. The theme is that first it is getting sorry. First the material is heated up to its upper critical temperature and allowing it to cool it still air. Okay, that is the option. Okay, so that is what normalizing process is all about. Not only steel, every metal is when it is normalized, it will reach its upper critical temperature, and then cooling process is done gradually. Okay, it is not put into a cooling furnace, or it is not rapidly cooled, or it is not dipped in uh, a vessel of water or something. Okay, it is cooled under only what room temperature. Okay, so we have come to the end of fourth question right now. So coming to the fifth question, uh, it comes from what subject? It, ECM is from your unconventional machining process. Okay, this also comes under manufacturing engineering. Okay, so let us move on to the fifth question. So here is the fifth question. In ECM, ECM means electrochemical machining. Okay, ECM means electrochemical machining. The material removal is due to, okay, what is responsible for metal removal? That is the question. Okay, in ECM process, what is the responsible thing for removing the metal? That is your question. So answer is option A, corrosion, option B, erosion, and option C, fusion, and option D, ion displacement. This was the question which was asked during the year of 2004, and it also carries one mark. Okay. So first you have to know about what is ECM process. It is also a metal removal process. It's not a metal adding process. It is a metal removal process. Um, in this particular process, chemical reaction occurs. Okay, chemical reaction occurs to remove the material. Okay, here a chemical reaction is occurring in order to remove the material. In order to reduce the removal of the material means that reducing the size of the component. Okay, so the particular chemical process happening here is electrolysis. So let me say about what is electrolysis now. Electrolysis is nothing but a process of decomposing ionic compounds. Each metal has its own ionic compounds, you know that very well, into their element by passing a direct electric current. We are going to pass the electric current directly into the material. Then, due to that decomposing of ionic components, the metal will get removed. Okay, so let's move on to the answer now. So the answer is option D. Okay. So let us see the explanation also. In ECM, the principle of electrolysis is used for removing the metal from the workpiece. Okay, so electrolysis is nothing but decomposing ionic components. So the ionic components are getting what to say is the ionic components are losing its strength, and then it is getting removed from the parent material. Okay, it no longer stays with the parent material. It just getting removed from the parent material, and that causes metal removal from the parent material. Okay. The next point is the material removal is due to ionic displacement. Also, it is the definition for it is the principle of electrolysis process. Ion displacement is happening over here. That is the main theme of this electrochemical machining process. Okay, right. Hope you have noted the answer. So for ECM process, the metal removal rate, sorry, I mean the metal removal happens due to what? Fusion. Right. So let's move on to the next question. So question number 5. Okay, well, so answer is option D. Sorry, ion displacement. So let us move on to the question number 6. So question number 6 was asked in the year 2011, and it also carries one mark. Um, it comes under powder metallurgy process. Okay, the operation in which oil is permeated into the course of a powder metallurgy product is known as. Okay, so first we have to know about what is the powder metallurgy. Okay, mixing of you have studied about stir casting and all. Yeah, stir casting is a process of we are using metal in the form of what to say metal in the form of powder, and in addition to that we'll be adding some binders along with it. It is also it is also more or less similar to that particular method. So the operation in which oil is permeated into the course of the powder metallurgy product is known as. Okay, product is manufactured with the help of powder metallurgy, but it is of defective component. Okay, we find some pores in that particular component. So, yeah. So
So in order to fill the pores, what oil is permeated. Okay. So in what is permeated? That is the question. So the option comes like this. Option A is mixing. Option B is sintering. Option C is impregnation. And option D is infiltration. So mixing, sintering, impregnation, and infiltration, all you know that already. Okay. Let us go on to the let us move on to the answer. So option is C. So it means that it is impregnated. Okay. Impregnated is nothing but it is enhancing the property of the material. Okay. Already some property is there, but still the force is considered as a defect in that component. So, yeah. So the force has to be filled with some other means of methods. Okay. Here we are using to enhance its property. Okay. So let us see the explanation. If the pores, filter, compact are filled with an oil, okay, the operation is called as impregnation. If the process in a what process they have given as powder metallurgy, the product is manufactured under powder metallurgy process, but still the pores are present in that. Okay, if we use oil to fill that pores, it means that it is impregnated. Okay, the material is impregnated. Material gets more fertile. Okay, the lubricants are added to porous bearing gears and lump rotors. So bearings, gears, and pumps are the product that are manufactured using powder metallurgy. Okay. Right. Next question. Question number 7. Sand mold indicates that. What is green sand mold? That is the question. So what is green sand mold is the question. So this question was asked in the year 2011, and it also carries 1 mark. Okay. So let us go to the options now. Option A, polymetric mold has been cured. They are asking about what is the meaning of green sand. Okay, so the option comes like this: polymetric molds has been cured. That's your first option. Next option is option B: mold has been totally dried. Okay, molds has been totally dried. So third option is mold is green in color. Then last option is mold contains moisture. Okay, so polymetric molds has been cured. Polymetric molds is nothing but polymer. It means that it is a plastic mold. So for green for manufacturing plastic components, we are not going to use sand as a mold. Okay, we have n number of manufacturing process for especially for producing polymetric products, right? So green sand mold has no work with polymetric molds, so we can ignore that particular option. So next is mold has been totally dried. Okay, we all know in manufacturing technology, first unit we have metal casting process is your first unit. Okay. So in that first unit, you would have already learned about green sand, and we have already learned about what are the types of sand available, and especially we have learned a lot about green sand and dry sand. Okay. So green sand, we have only two options, right? Um, Either it should be dry or it should contain some moisture. So next option C is mold green in color. It is totally what to say? It is totally unmatchable. Then option D is mold contains moisture. Yeah. So this might be the right answer. This should be the right answer because when it contains moisture, when the sand contains moisture, we will call it as green sand. And when the moisture is removed from the sand, it is called as dry sand. Okay. That are the two sand which we are using in metal casting process for especially for making this mold. So the option should be moisture. The mold should contain moisture should be the answer. Let us see the answer now. Okay, option is D. The answer is right. Okay, let us see the explanation now. The explanation is a green sand mold is composed of mixture of sand, silica sand SiO2, clay, which acts as a binder and water. Okay, so when we are adding water, it means that it should contain some amount of moisture. Okay, so also clay is always contains some amount of water. So, yeah. Uh, so sand is dry sand. It has its own grain rate and all those stuff. Okay. And in case of green sand, it is not a particular sand, but it is a mixture of sand. Okay, a mixture of normal sand, nothing but our what to say, uh, sea sand or something, beach sand or something. This is called as sand. Then it is followed by clay and also water. When we mix all these three, it becomes a green sand. So it contains some moisture is clearly indicated in this first point. Okay. So next point is the word green is associated with the condition of wetness. Okay, it means that the word green is meant for representing that the material, I mean the mold condition is still in wet condition. Okay, so that they are wet, right? The word green is associated with the condition of wetness or freshness, and because of the mold, is left in the damp condition. Damp condition in the sense it should contain some amount of water, and hence the name is called as green sand. Okay. Now we can. I hope you can clearly understand. So green sand mold is when green sand mold, when you see this question comes in your question paper, you should definitely not get confused with other answers. So green sand mold, if you see green sand mold on the question paper, it should what should come in your mind is it should contain some amount of moisture. Okay, note it down. Green sand mold indicates that mold contains some amount of moisture. That is the right answer. Okay. So next question. Question number 8. Question number 8 is which among the following welding process? Which among the following welding process uses non-consumable electrode? Which among the welding process uses non-consumable electrode? That is the question. Okay. Let us
See the options now. First is gas welding. Next is submerged arc welding. So next option is gas tungsten arc welding and flux coated arc welding. These are the options available here. So this was the question which was asked in the year 2011, and it also carries 1 mark. Okay. Let us see the question once again. Which one among the following welding process uses non-consumable electrode? Okay, which uses non-consumable electrode. So in case of gas metal arc welding, we are using filler metal. Yeah, the filler metal is considered as an electrode in case of gas welding. Okay, so the filler metal will get melted up and it will fill the gap between the two metals. Okay, so that won't be the right answer. So option B, submerged arc welding. Yeah, submerged arc welding also, either it is flux is not coated in the electrode. The electrode using in this particular submerged arc welding is a type of consumable electrode only. Okay, because you would have seen those videos also. I have shown you already about videos on submerged arc welding and everything. So in this particular case, what we are using is we are using bare electrode. Bare electrode is nothing but it won't the electrode will not be surrounded by flux coating. Okay, that is called as bare electrode. So it means that submerged arc welding uses consumable electrode. Okay, the consumable electrode will be in the form of reel. Okay, we will have a feeding unit. We will have a separate feeding unit for the submerged arc welding. We have already seen that. So you clearly know that that will be not the right answer. The next thing is gas tungsten arc welding. Okay, tungsten arc welding. Okay, let us move on to the next option. After completing option D, we will come to option C. Flux coated arc welding. Yeah, flux coated arc welding is clearly indicate this particular option clearly indicates that they are using electrode. Okay, so that won't be the right answer. So let us move on to option C now. Gas tungsten arc welding. Okay, so we all know very well that tungsten is highly resistive to temperature. Okay, so its melting point. What I mean is its melting point is very high. So compared to the other answer, I think gas tungsten arc welding should be the right answer. It has another name as TIG welding. Yeah, tungsten inert gas welding. We would have learned in that in manufacturing technology 1 second unit. Okay, welding process, metal joining process. We would have learned this these all type of welding processes. Okay, so option is option C, gas tungsten arc welding, GTAW. In short form, we will call it as GTAW. It is also called as tungsten inert gas field. Okay. So the purpose of inert gas, you already know, inert gas is a surrounding gas which never allows atmospheric air to interact between those interact in the welding area. Okay. So in case of atmospheric interaction, the product manufactured, I mean the weld will not be a proper welding. It will definitely be a defective welding, which will carry some amount of force in it. Okay. So gas tungsten arc welding is also called as tungsten inert gas welding. Tungsten has a melting point about 340 degrees Celsius. They have given the option over here. I mean the point over here. The electrode is non-consumable electrode. Since the melting point is above 340 degrees Celsius. Okay. So it will never get melted so easy. It will get melted, but it's not so easy to melt tungsten. Okay. The arc is maintained between the second point they have given us. The arc is maintained between the workpiece and the tungsten electrode by an inert gas. Okay. So the arc is the one which helps the what to say, which helps the weldment to not react with the atmosphere. Okay. Right. So next question. Manufacturing engineering comes to the here we come to the next question. Question number 9. The crystal structure of austenite is is body centered cubic, face centered cubic, hexagonal closed pack, and body centered tetragonal. Okay, what will be the crystal structure of austenite? That is the question. So this question was asked in the year 2011, and it also carries 1 mark. Okay, so option B is the right answer. So it has face centered cubic. Okay, so in each face there will be a there will be an ion present in the center of the face. Okay, so the answer explanation comes like this: austenite is a solid solution of carbon in gamma ion. It has FEC structure. Okay, it has face centered cubic structure. So austenite has face centered cubic structure. It has a solid solubility up to 2% carbon and 1000 degrees Celsius. Okay, it is soluble it gets soluble at only 1200 degrees Celsius. Okay, that is the right answer. Please make a note. The crystal structure of austenite is face centered cubic structure. Okay, right. Let us move on to the next question. Question number 10. Again, a match the following question. Match the following non-traditional machining process with the corresponding material removal mechanism. Okay. Non-traditional mechanism is nothing but unconventional machining process. Okay. This comes under unconventional machining process. So the machining process are listed like this. The first machining process is chemical machining. Second option is electrochemical machining. Third option is electro-discharge machining. And the last option is ultrasonic machining. Okay. So the mechanism for metal removal is option 1, erosion, option 2, corrosive reaction, and option 3, ion displacement, and option 4, fusion and vaporization. So yeah, first it gets fuses and then it will get vaporized. Okay. And this was the question which was asked in the year 2011, and it also carries 2 marks. Okay. This is a 2 mark question. Okay, we will be getting both 1 mark and 2 mark question, but be very careful because of negative marking. So yeah, in gate questions we have negative marking. You should be very careful. Only if you are very confident with your answers, you can go with it. Okay. When you are not confident, just leave the question. And finally, after completing all the questions, come back to this question. Think once again. When you are confident, then you can go with your answer. Okay. Right. So the options are they have matched some options already. Let us see. For chemical machining, they have matched it with corrosive reaction. Then for electrochemical machining, they have matched it with ion displacement. And electro-discharge machining, they have matched it with fusion and vaporization. And ultrasonic machining, they have matched it with erosion. Okay, this is your first option. Then coming to the option B, chemical machining is chosen with corrosive reaction. Then electrochemical machining is matched with fusion and vaporization. Electro-discharge machining is matched with ion displacement, and ultrasonic machining is matched with erosion. So what will be the right answer? Okay. Then coming to the option C. Option C, chemical machining. Chemical machining is matched with ion displacement again. Then electrochemical machining is matched with corrosive reaction, and the electro discharge machining is matched with fusion and vaporization, and ultrasonic machining is matched with erosion. Okay. Then let us move on to the option D. Chemical machining is matched with corrosive reaction, and the electrochemical machining is matched with ion displacement. Electro discharge machining is matched with erosion, and finally ultrasonic machining is matched with fusion and vaporization. Okay. Let us check the answer now. So option A is the answer. So option A indicates left hand side is your machining process and right hand side is your metal removal process. For chemical machining, it is corrosive reaction. We have already seen. Okay. We have already seen ion displacement in the case of electrochemical machining. ECM we have already seen. One question was there. Okay. Okay. For chemical machining, it is corrosive reaction. For electrochemical machining, it is smashed with ion displacement. Electro discharge machining is smashed with fusion and vaporization, and ultrasonic machining is smashed with erosion. So the correct pair of answer is option A, P22, Q23, and R24, DS21. This is the right answer. Okay. So please make a note of it. Right. Hope you have noted the question and answer. So let us move on to the question number 11. It was asked in the year 2010 and it carries 1 mark. Okay. The material property which depends only on the basic crystal structure. Yeah. The material property only depends on the basic crystal structure. They have asked this question and they have given some options like option A, fatigue strength, option B, work hardening, option C, fracture strength, and last option is elastic limit. Okay. So we all know that every material has its own material property. And here the question is the material property which depends on only, depends only on basic crystal structure. The basic crystal structure itself defines the material property. Okay. So let us see what are the options. So for fatigue, it is also called as endurance limit. Endurance limit is nothing but the stress below which a number of loading cycles can be given. Multiple number of loading cycles can be given before it gets collapsed. That is called as fatigue strength. So fatigue is also known as you have to note it down. Okay. Maybe in interviews also you will get what is the other name? Get a question like what is the other name of fatigue? You should say that it is nothing but endurance limit. Okay. Right. So next question is work hardening. Next option is work hardening. So work hardening, what is work hardening? Work hardening is a property of plastic deformation. Okay, it undergoes plastic deformation. It has this plastic limit and also elastic limit. Okay. Okay. Next is fracture strength. So fracture strength is nothing but the ability to resist failure when loading. Yeah. When a particular load is applied on the material, it should resist failure. Okay. It should not collapse. It should not collapse at the moment when the load is acting. It should resist the loading. Okay, that is fracture strength. And last is elastic limit. Elastic limit we already know. Okay, it will undergo a prolonged extension, and after the when loaded, and after the load is removed, it again comes to its original state. That is elastic limit. Okay, let us see the answer now. So the answer is option C. Option C is fracture strength. The material property which depends only on the basic crystal structure. Yeah. So basic crystal is the crystal should have fracture strength. It should not break at once. Yeah. When loaded, it should be having some amount of resistive strength. Okay, that is called as fracture strength. Okay. So the fracture strength may be a material property which depends on the basic crystal structure. Fracture strength depends on the strength of the material alone. Okay. So the crystal strength defines the defines the material property. Okay. Right. Then
the next question is, in a gating system, the ratio 1:2:4 represents. Okay, you know what is the gating system is all about. The question is, in a gating system, the ratio 1:2:4 represent what? Okay, that is your question. So your options are option A, sprue base area, runner area, and in-gate area, and option B, pouring basin area, in-gate area, and runner area, and option C, sprue base area, in-gate area, and casting area, and option 4 is runner area, in-gate area, and casting area. Okay, this question is also from the year of 2010, and it also carries 1 mark. Okay, right. So in order to answer this question, you must know what is sprue and what is runner and what is in-gate. All you should know. Okay, so sprue is what through which the molten metal is poured. Okay, so sprue is nothing but a funnel like structure through which we are pouring the molten metal. Okay, that is called as sprue. Then coming to the runner area is where the passage for the metal flow. Okay, for the passage of metal we are producing a runner. And also what it mean by in-gate is, it is basically where the casting material gets entered into. Okay, entered into the mold cavity, where the casting metal entered into the mold cavity. Let us see the answer first. So option A is the right answer. So gate ratio is defined as the ratio of sprue base area followed by the total runner area and then the in-gate area. Okay, this is the right answer. Okay, please make a note of it. Right? Okay, then we will move on to the 13th question. So coming to the 13th question, it comes in manufacturing technology 2. Unit number 5 is what CNC program is all about. Okay, so it is of CNC programming question. So in a CNC mesh program block, N002, G02, G91, X40, Z40, and it goes on, where G02 and G91 refers what? Okay, they are asking about only G02 and G91. Okay, the option counterclockwise direction and absolute dimension, circular interpolation in clockwise direction and incremental dimension, and the last option is circular interpolation in clockwise direction and absolute dimension. Okay, this was the question asked in the year 2010, which carries 1 mark. Okay, let us see what the answer is. So the answer C is the right option. So G02 represents circular interpolation in clockwise direction and G91 represents incremental dimension. This both comes under G codes. You know what is G codes and M codes. Okay, so M codes means the miscellaneous codes, right? Okay, right. So let us move on to the next question. Question number 14. This is also from manufacturing technology 2. The question is, friction at the tool chip interface can be reduced by. Okay, friction at the tool chip interface can be reduced by what factor? That is our question. The option comes like this: decreasing the rake angle. Option A is decreasing the rake angle. Option B is increasing the depth of cut. Option B is increasing the depth of cut. And option C is decreasing the cutting speed. And the last option is increasing the cutting speed. Okay, so what has to be reduced is the friction. The friction has to be reduced between the tool and the chip interface. When the tool and chip interface, the friction has to be reduced. That is our question. Okay, so let us see the answer and explanation. So option D is the right answer. What is option D? Increasing the cutting speed. Okay, it means that the contact area of the tool and the workpiece should be maintained minimum. So yeah, the cutting while doing a machining operation with the help of lathe single point cutting tool, the contact area between the tool and the workpiece should be maintained minimum. Okay, so why this is, when the tool and the workpiece contact area gets increased, it results in large amount of friction. Okay, large amount of friction results in heat development, and heat development results in failure of tool. Okay, so the only method for reducing friction is by increasing the cutting speed. The cutting speed has to be increased. Okay, that is the answer. Okay, let us see the explanation again. The cutting forces decreases with an increasing in cutting speed. Okay, when the amount of force applied on the material will get decreased while increasing the cutting speed. That is what they are trying to say over there, but it is substantially smaller than the increase in speed. Okay, next point is, with the increase in speed, friction decreases at the tool chip interface. When the speed of the machinability gets increased, the friction also get reduced, because the contact area is very less, so there is no possibility for friction to get increased. Okay, that is the answer. The thickness of the chip reduces by increasing the speed, so there is no friction. Results in what? Tool life can be enhanced, right? So next question, question number 15. Two streams of liquid metal, two seams of liquid metal which are not hot enough to fuse properly results into a casting defect known as. Okay, we are pouring liquid metal in various in two areas. So yeah, from two areas we are pouring the molten metal, but there is a defect. Okay, while fusing, when the two pouring of what to say, when the liquid from the two ends gets mixed up, there is a defect occurring. What type of defect is it? That is the question. Okay, so option A is cold shed, option B swell, option C is sand wash, and option D is scab. Okay, these are the options, and we have to select the right answer from here. This was the question from the year of 2009, which carries also 1 marks. Okay, so what you have to see over here is, first point, two streams of liquid. So we are pouring the molten metal from two different ends, and the molten metal will flow into the screw, and all, and in the mold cavity it will get it will meet one another. Okay, the meeting at that particular meeting point, there will be a defect. Okay, in case if you are not properly heating the metal, and we are not properly maintaining the if you are not properly maintaining the temperature, the defect may occur. They are asking about what type of defect can occur in that particular point. Okay, so let us see the answer. But before that, we have to note this point. Okay, if the metal solidifies unevenly, and so it won't fuses together properly. Okay, if the metal solidifies unevenly, we are pouring the molten metal from two different ends, so the what to say, due to atmospheric interaction and other factors, the molten metal may lose its heat. Okay, it may radiate its heat, and it fuses at different temperature. Okay, that may be a point, and that causes a hollow area on the point of interaction. Okay, that causes a hollow area. Hollow area is nothing but voids. Okay, voids, or we can say it as vents. Okay, point of interaction of the two liquid metal. That will be the answer. So the answer should be option A. Option A is cold shed. Okay, so two streams of liquid metal are not hot enough to fuse properly. Okay, that is the point, resulting into a casting defect known as cold shed. Okay, this defect is same as in the sand molding process. Okay, we are mostly we are facing this problem in sand molding process only. Okay, so this possibility of this defects may be these 2 points: cooling of die or loss of plasticity of heat of the metal. Okay, so loss of plasticity means the metal is no longer in plastic state. It has lost its plastic state, and it had attained its what? At metal state. Okay, so it will no longer be in plastic state. If it is in plastic state, the fusion will be in a much better way. Okay, if it has lost its plastic state. Okay, next thing is pouring speed is less. Okay, it is also should be considered as a main point. Okay, pouring speed has to be maintained, and the speed has to be the same in both the basins. Okay, in both the pairing or pouring basins, the speed has to be same. Okay, there should not be any deviations in speed. Okay, nowadays it has been done with the help of some machines, and also robots, so there is not a possibility for getting this defect. Okay, right. So moving on to the next question, question number 16. Which of the following is the correct data structure of solid models? Okay, solid models. In what way we have to represent a solid model? That is our question. In the year of 2009, it has been asked, and it also carries 1 mark. Okay, so Let us see the options over here. Option A, solid part, faces, edges, and vertices. And option B, solid part, edges, faces, and vertices. Option C, vertices, edges, faces, solid parts. And last option is vertices, faces, edges, and solid parts. Okay. So first we have to know about what are vertices, faces, edges, and solid parts. Okay, for defining a solid model, what are the factors to be considered is these factors. Okay, the first one is vertices. Vertices is the highest peak. If you are considering a solid object, it is of in case it is of amoeboid shape, means we have to find the highest peak of the object. Okay, then we have to consider about the edges. Edges is nothing but number of corners it has. Okay, whether it is a cuboid shape or a cube shape or a circle or a square, it has to be calculated for its edges, number of edges, how many edges it is having. We have to note it down. And the next thing is faces, how many faces a square or a cube has. And last thing is solid part. Solid part in what shape, whether it may be a square, it may be a circle, it may be a sphere, whatever shape it may be. Okay, so the right answer is, first we have to represent its vertices, followed by its edges, then followed by faces, and finally solid part. This is the right way to represent a solid structure, solid model. Okay, please make a note. Which of the following is the correct data for structure of solid model? In what way the solid model has to be represented? The answer is vertices, edges, faces, and solid parts. Right? Okay. Coming to the next question, question number 17 is again a match the following question. So we have NC codes on the right hand side and its definitions on the left hand side. We have to match these codes with these definitions, right? So the first code is M051, then the second is G012, the third is G043, and the last is G094. And here for definition, it has been on the right hand side, it has been given as absolute coordinate system, dual, spindle stop, and linear interpolation. What is the right option? Okay, let us see the option without wasting the time and discussing about what are the options given. Let us see the answers first. Option C is the right answer. So option C is M051 is matched with spindle stop, and G012 is matched with dual, and linear interpolation, and option R, G043 is matched with dual time, and option S, G094 is matched with absolute coordinate system. So the right answer is option C is the right answer. Okay, P to 3, Q to 4, R to 2, and S to 1. This is the right answer. Okay. So only if you know about G codes and M codes, we will be getting a right answer over here. Okay, we have to be very careful and we have to be very you should have by hearted this G codes and M codes. Okay, general codes and miscellaneous codes you have to by heart. Okay, then only you can face these types of questions. Right. So next, move on to the next question. Question number 18. Internal gear cutting operation can be performed by. Okay, we have to be very careful while reading this question whether it is given as internal or external gear. Okay, there is a lot of difference between internal and external gear. Okay, internal gear means we will be having a gear profile on the inner diameter of the blank, and if it is on external gear means we will be having on the external diameter. Okay, this you have studied during second year in MT2 subject. Okay, where a small pinion gear will be used. Okay, for cutting internal gear, we will be using a pinion cutter. So let us see the options over here. Option A is milling machine, and option B is shaping with the rack cutter. Okay, rack cutter, and option C is shaping with pinion cutter, and option D is hobbing. Okay, so let us discuss the options now. So milling operation, we will be using it for external gear profile only. So yeah, the milling operation has no work to do with internal gear. Then after that, second point, shaping with rack cutter. Rack cutter is not at all possible to cut an internal gear. Okay, it is only capable of cutting a profile in external diameter. Okay, so option C is shaping with pinion cutter. Pinion cutter. Okay, so here the answer is the pinion cutter, because we'll be using a pinion cutter. You have been well aware of pinion cutter, because with the help of pinion cutter only it is possible to cut the gear profile on the internal diameter. And last thing is hobbing. Hobbing is also meant for cutting external diameter. You would have seen in MT1 lab also, we have a hobbing machine which cuts only the which is capable of making only a profile on the outer diameter of the blank. Okay, this was the question asked in the year 2008, and which carries 1 mark. And the option for the right answer for this question is shaping with pinion cutter. Right, so here the explanation has been given. Internal gear cutting operation can be performed by shaping with pinion cutter only. In the case of rotating pinion type cutter, such an indexing is not required, because in pinion cutter we will be you know what is indexing is all about. Okay, for maintaining equal distance between the two gear profile, we'll be handling this indexing mechanism in this machine, in shaper machine. Okay, you have to know about what is indexing also. Okay, right. So next question is question number 19. Which of the following engineering material is the most suitable candidate for hot chamber die casting? Okay, you know very well about hot chamber and cold chamber die casting, and options are low carbon steel, option B titanium, option C is copper, and finally option D is tin. Okay, let us now discuss about what is hot chamber die casting and cold chamber die casting. There is a small difference in construction, where in case of hot chamber die casting we will be having a we'll be having a heating element as an integral part of the machine. Okay, we'll be having the heating element as an integral part of the machine in case of hot chamber die casting, whereas the heating element will not be an part of the machine. Will not be an integral part of the machine. Heating happens in some other area, and with the help of ladle we'll be taking the molten metal and pouring into this cold chamber die casting. Okay, cold chamber die casting unit. Okay, so here the question is about hot chamber die casting. Which of the following engineering material is the most suitable candidate for hot chamber die casting? Okay, so it means that hot chamber die casting is meant only for low melting point alloys. Okay, we will be using hot chamber die casting for only casting what um, low melting point alloys only. We'll be handling it with hot chamber die casting. So the answer may be option D, tin. Okay, compared to low carbon steel, titanium, and copper, tin has a lowest melting point. Okay, and thus the answer should be option D. The explanation is here. The hot chamber die casting process is used for low melting temperature alloys, as I said before. Okay, among these options, tin is the lowest melting point alloy. Right, so the option is option D. The right answer is option D. Okay. Then coming to the next question, manufacturing engineering again. Which one of the following is a solid state joining process? Okay, here it comes under manufacturing technology 1, unit 2, metal joining process, and what type of welding is used for joining solid state joining. What is a solid state joining process? Okay, so in the case of the options are here: gas tungsten arc welding, resistance spot welding, friction welding, and submerged arc welding. Okay, we have these options, and the option 1 is gas tungsten arc welding, option B is resistance spot welding, friction welding, and submerged arc welding. Right, so what is a solid state welding? That is the question. This was the question asked in the year 2007. Okay, so gas tungsten arc welding, we will be using what? We will be using an non-consumable electrode. Okay, there is no contact between this electrode, non-contact, what to say, tungsten electrode and the workpiece. So this won't be the right answer. So resistance spot welding is one which is carried out with the help of resistance between resistance for electric current. Okay, so resistance spot welding will not be an not be the answer. Okay, then option D, submerged arc welding. Submerged arc welding also will be using a consumable electrode, and it's not a type of solid state welding. So the only answer is friction welding, where we won't be using any type of what electrode. Maybe it may be a consumable electrode or non-consumable electrode, bare electrode or flux coated electrode. We will not be using any type of electrode, only in the case of friction welding, and that is it's called as solid state welding. Okay, solid state joining is the method by which metals are joined without the use of electrode. Okay, we are not using any type of electrode in this particular welding process. That is called as what? Friction welding. Okay, you know that friction welding has two types of two types in it: friction welding and friction stir welding. Okay, so it means that the two metals directly interact with each other, and it's joined by the action of heat and friction. The friction produces heat, and heat produces coalescence of metal. Okay, coalescence is nothing but converting into a plastic state, right? So the answer is friction welding. Okay, the explanation is also given over here. Friction welding is defined as a solid state welding process wherein coalescence is produced by heat obtained from mechanically induced sliding motion between rubbing surfaces. Okay, the surface of the two metals will be um, rubbing each other, thereby results in producing heat. Due to that friction, it results in producing heat. The heat development results in coalescence, and finally, by application of force on either side, the metal will be joined and it will be converted into a single piece. Okay, right. So coming to the next question. Next question is, which type of motor is not used in axis of spindle drive or CNC machine tools? Okay, which type of motor is not used in axis of spindle drive? Okay, in the spindle, we have seen CNC machine. In that particular CNC machine, what type of motor is not advisable to be used? Okay, the first option is induction motor. Second option is DC motor. Third option is stepper motor, and option D is servo motor. Okay, in this what to say, in this option, stepper motor alone you may not be aware of. Okay, stepper motor is in mechatronics you would have been studied about stepper motor. We have three types of stepper motors, where we have variable reluctance stepper motor, then we have permanent magnet stepper motor, and hybrid stepper motor. Okay, why I am concentrating only on stepper motor is, other than stepper motor, all the three options are continuous motors. Okay, servo motor is capable of rotating in both clockwise and anti-clockwise direction, same as the type of stepper motor. But the only difference is stepper motor is moves step by step motion. Okay, it handles the step by step motion. But whereas linear servo motor and all, it is a continuous type motor. Even DC servo motor is also a continuous type motor, and induction motor is also a continuous motor. Okay, only stepper motor is connected to a mechatronics, what to say, a microprocessor or a microcontroller, and then only we can connect it to a system. Okay, so stepper motor is capable of, it's also capable of rotating in both clockwise and counterclockwise direction. But the only difference is it rotates in torque is high, because its rotation is not continuous. Okay, let us see the explanation over here. The spindle motor is a small motor with high precision, high reliability, and electric motor. Is used to rotate the shaft or spindle used in a machine tool for performing a wide range of tasks. Okay, we are using a spindle motor in a continuous spindle motor. We are using only for a continuous operation. So a stepper motor have not all these characteristics. Okay, above characteristics are not satisfied by stepper motor, and the odd man out is the stepper motor. Okay, so the option is option C, stepper motor. Right? Okay. Hope you understand. So question number 22. In electro-discharge machining (EDM) process, if thermal conductivity of the tool is high and the specific heat of the workpiece is low, then the tool wear rate and the material removal rate are expected to be respectively. They are asking about what will be the cause of tool wear and metal removal rate when in the case of EDM process. Okay, if the thermal conductivity of the tool is high, in case if the thermal conductivity of the tool is high, what happens to wear rate and metal removal rate? That is our question. Asked in the year 2007. Okay, the options are it both will be high. wear rate and metal removal rate will be high. Next option is both will be low, and option C is high and low. Tool rate will be high and MRR will be low, and finally tool wear will be low and MRR will be high. That is the option. Let us see the solution. The solution is metal removal rate depends upon current density. Okay, metal removal rate is completely dependent upon current density, how much current you are giving. Okay, the MRR increase with thermal conductivity also. The metal removal rate also increases with thermal conductivity, because in case if the temperature of the material increases, the metal removal rate will also be increased. Okay, it is directly proportional, right? So we have to know about wear ratio, where wear ratio is given by volume of the metal removed work divided by volume of metal removed the tool. Okay, right. The volume of the metal removed from the tool is very less compared to the volume of the metal removed from the work. Okay, when compared to tool and work, tool is we all know tool will be subjected to heat treatment and other mechanical properties enhancement will be done for tool only and not workpiece. Okay, so thus tool has a higher ability to resist external forces and external heat or friction and everything. Okay, when compared to work, I mean workpiece. Okay. So wear ratio is directly proportional to volume of metal removed work. Hence, both wear rate and MRR rate are expected to be high. So option A should be high. When the metal removal rate is high, tool wear is also high. Okay. Amount of material removed from the metal increases, tool wear also will be increased. Okay. So next is question number 23. Expendable pattern is used in. Okay, an expendable pattern is useful. Okay, you know about extended pattern, and it is a very easy question. You would have found the answer by now. Okay, so first is flush casting, squeeze casting, centrifugal casting, and investment casting. Okay, so they have said that we are using an expendable pattern. So it means flush casting that doesn't require a pattern. Squeeze casting, it requires a pattern, but squeezing operation is what? If we are using an expandable mold, it is not possible to squeeze. Okay, it will expand much larger. Okay, and the centrifugal casting doesn't require a pattern. Okay, for making pipes or circular hollow structure, it doesn't require a pattern, so that won't be the right answer. And option D is investment casting, where we'll be using expandable mold. Yes, so the answer should be investment casting. Okay, so investment casting causes an expandable pattern which is made of wax. You know, we all know we will be using wax or plastic. Okay, it is also called investment casting is also called as what? We have another name for investment casting. Do you remember? What name? We'll also call it as lost wax. Okay, lost wax casting process. Okay, so lost wax is the wax will be melted out. Okay, that is called as lost wax. Okay, so this pattern is made by injecting molten wax or plastic into a metal die in a shape of the pattern. What shape the pattern should be, and that shape the wax or plastic pattern should be manufactured. Okay, so why we are using wax or plastic patterns is for maintaining the surface finish. Okay, the product made out of investment casting does not require. It should be. You should know this point. The product manufactured out of investment casting machine does not require any surface finishing operation. Okay, its RR will be very high. Okay, RR is nothing but its roughness. Okay, roughness will be roughness will be very low. Okay, it doesn't require any further processing for surface finish, right? Okay, so next question is the main purpose of periodizing treatment is to improve. Okay, improve what? For what purpose we are using periodizing treatment process for a material? Options are hardenability of low carbon steel, machinability of low carbon steel, hardenability of high carbon steel, or machinability of high carbon steel. Okay, so what purpose we are going for periodizing process? Okay, so first we have to know about what is periodizing process. So periodizing is also called as a heat treatment process of iron based alloys. Okay, it is not for non-iron material. It is only for iron-based alloys. Commonly carbon steels in order to convert them into a ductile and malleable alloy. Okay, so it means that the metal will be very hard, so it is highly a tedious process to machine it. Okay, so for machining purpose, we have to change the material property of a material. Okay, for thus we have what we have carried out the spheroidizing process, where the machinability will get increased. Okay, the product will be very hard, so it is machinability is not possible. So what has to be done is the material property of the metal has to be changed. For that purpose, we are going for spheroidizing process. Okay, so spheroidizing may be defined as any heat treatment process that produces a rounded or globular form of carbide. Okay, the carbon steel are spheroidized to improve the machinability. Okay, we have to improve the machinability, especially in continuous cutting operation. Continuous cutting operations like lathe drilling, these are continuous cutting operation. Okay, so option D. Option D is machinability of high carbon steel. Okay, high carbon steel is what to say, highly enhanced property it contains. Okay, high carbon steel contains highly enhanced material property, so the material property has to be reduced. Okay, for that particular process, spheroidizing process is carried out. Right. So next question is, a ring gauge is used to measure what? Okay, you know about ring gauge. You would have seen in metrology and measurement subject what is ring gauge. Okay, it is used to measure, whether it is used to measure the diameter but not the roundness, and option 2 is roundness but not the outside diameter. Both outside diameter and roundness can be measured using ring gauge, and only external threads can be measured. Okay, so first we have to know about what is ring gauge is all about. Okay, so roundness can be measured only with the use of digital gauges. Okay, that you should make clear. Okay, the roundness of the metal should be measured only with the help of digital or analog gauges. For example, we have needle gauge. We will be having needle gauge. Then on the we will have a plunger dial. So we have a much lot of equipment for finding the roundness of the metal. But outside diameter, but not the roundness, can be measured with the help of ring gauge. So that should be the correct answer. Then external thread. There is no maybe for examining the what to say, quality of the external thread. We have a separate gauge called thread gauges. Okay, we have thread gauges, internal thread gauge and external thread gauge we have. So ring gauge has no work to do with threads and all. Okay, so the right answer must be only for measuring the outer diameter and not the roundness. Okay, so option should be option A. Okay, the ring gauges are used for gauging the shaft and the male components, that is measure the outside diameter alone. Okay, it does not able to measure the roundness of the given shaft. Roundness cannot be measured with ring gauge. Okay, ring gauge is just why it is named as ring gauge is it just represents a ring. Okay, it has a profile of a ring only. Okay, it has no work to do with roundness and all. Okay. Okay, so next is question number 26. When the temperature of a solid metal increases, what will happen? Okay, when the temperature of a solid metal increases, what will happen inside the metal? That is the question. Option A, strength of the metal decreases but ductility increases. Option B, both strength and ductility of the metal decreases. Option C, both strength and ductility of the metal increases. And last option D, strength of the metal increases but ductility decreases. Okay, let us choose from this. And it was asked in the year 2005. One more question. Okay, so let us see what happens. When heat is applied to the metal, the strength of the metal will decrease completely. Okay, that should be considered. When we are heating a metal, it loses its some property, and it also gains some property. Okay, but the strength will be completely out of control. Okay, when the heat is applied to the metal, the strength of the metal will decrease compulsorily due to the breaking of intermolecular bonding. Okay, so in a solid the intermolecular interaction, I mean intermolecular bonding will be very high when compared to gas and liquid. Okay, so while heating, it loses its bonding ability, and that's why the solid is getting converted into liquid form. Okay, it loses its bonding ability, and that's why it is getting converted into from solid to liquid form when we are heating it. Okay, so the option will be option A, where the strength of the metal decreases, but ductility increases. Ductility in the sense its plastics or elastic limit is called ductility. So the ductility may be increased, right? So okay, let us see the explanation. The temperature of the solid metal increases, its intramolecular bond or break, and strength of the solid metal decreases. Okay, due to the intermolecular attraction breaking, there won't be good strength in the metal. Okay, due to the decrease in strength, the elongation of the metal increases. When we apply a load, that is ductility increases. Okay, so what is its elongation limit, its elastic limit, and also its plastic state will be increased. Plastic ability will be increased, and that's why it will resist some load. Okay, so next is question number 27. The mechanism of material removal in EDM process. Okay, in what type of metal removal is carried out in the EDM process? The question. Option A, melting and evaporization, melting and corrosion. Option C, erosion and cavitation, and option D, cavitation and evaporation. What is happening in EDM process? That is the question. Okay, so let us see the explanation. The answer is option A, melting and evaporation. First it gets melted and finally it gets evaporated on further heating. Okay. So in EDM process, the thermal energy is employed to melt and vaporize tiny particles of a work material by concentrating the heat energy on a smaller area of the workpiece. Okay. It just works like a laser. Okay. What laser does? If you are targeting a particular area with a laser, the continuous interaction of light on the particular surface will produce heat, and after that it will produce what to say it cannot resist the heat, and it just flows down. Okay, flows down as liquid. Okay, that is what is happening here. That in EDM process, the thermal energy is targeted only on a particular area, and that in that particular area the metal will be getting reduced. So the metal will be getting removed from it. So the MRR is metal removal process is done by melting and evaporation process. Okay, it completely gets evaporated. On further heating, on first heating, it will get converted into solid to liquid, and on further heating, the material gets vaporized. That is that. Okay. So next question number uh, 28. Cold working of steel is defined as working at what temperature? That is the question. Option A is at its recrystallization temperature. Option B, above its recrystallization temperature. Option C, below its recrystallization temperature. And option D, at 2/3 of melting temperature of the metal. Okay. Question asked in the year 2003 carries 1 mark. Okay. So in curl working process, what type of working is done? That is the question. So we have two types of working process. This we have seen in Unit 3, metal forming process in manufacturing technology 1. Okay, we have hot working and cold working process. In hot working process, what we'll do? We'll heat the metal up to its recrystallization temperature. Okay, recrystallization temperature is what about? It will change its structure. Okay, only when the metal is heated to its recrystallization temperature, we can change its structure. That is called as hot working. Okay, so let us see the answer over here. The answer is option C. Option C is what? Below its recrystallization temperature. Cold working, we already know. Okay, we don't have to waste the time more here. We know very well that recrystallization of cold working, for cold working, the temperature is maintained below the recrystallization temperature. No heat is employed in this particular machining. Particular working process. Okay. So next is question number 29. Quality screw threads are produced by what process? Good quality screw threads are produced by what process? Okay, we have the options as thread milling, thread chasing, thread cutting with special point tool, and the last option is thread casting. Okay, so thread casting, I think milling process we cannot mention threads on. Okay, it is very tedious. It is not possible also. Okay, and thread chasing is nothing but it is also a a metal cutting process. Then thread cutting with single point cutting tool. Single point cutting tool is what we do in lathe. Okay, lathe we are using you are carrying out threading operation, right? In a cylindrical block we are handling a threading operation. Okay, that is also not a precise method for preparing a thread. Okay, so there won't be much of quality when compared to other thread casting process. I mean thread making process. Okay, so the answer should be casting process. So in casting process only we can produce threads of good quality, right? Okay. So here comes the explanation. The quality threads are produced only by thread casting. Quality screw threads are made by die casting and permanent mold casting, and very accurate accurate and of high finish is properly made. Okay, so what this particular point means is permanent mold means is the mold is made up of what? Metal. So the threads also the quality of the thread also will be very good. Okay, so here is the last question for the session. Tree panning is performed for. Okay, tree panning also you will be having an operation performed by lathe in MT2. In manufacturing technology 2, you will be heard about this particular process, tree panning process. Okay, so let us see the options now. First option is finishing a drilled hole. Second option is producing a large hole without drilling, and third option is truing a hole for alignment, and the last option is enhancing a drill hole. Okay, sorry, I mean enlarging a drill hole. Okay, so finishing a drilled hole. Okay, what does finishing a drilled hole mean? Okay, if you are using a drill bit, when you see the surface of the drilled hole, okay, drilled hole, it will not be of correct manner. Okay, it needs some further what to say further surface finishing operation. Okay, for that operation, finishing of drill hole is employed, and this operation is called as reaming operation. Okay, that is called as, it is not called as tree panning operation, so we can omit that particular option. And producing a large hole without drilling. Okay, let us wait with this option. So we will go to the truing operation. Truing also operation is nothing but checking the alignment of the hole. If the alignment of the hole is not proper, we will be using a truing operation. And enlarging a drilled hole. Enlarging a drilled hole may be we'll be making a counter bore operation, or it may be it may be a reaming operation again. Okay, enlarging and finishing a drilled hole means it is reaming operation only. Okay, then we have completed the other three options. Coming to the option B, producing a large hole without drilling. That is the right answer. Okay, why is consider a compass with a pencil. Okay, you are drawing a circle, and the pencil tip. We have a pencil lead tip, right? So that tip is called a cutting tool, single point cutting tool. Okay, so what we are doing is continuously you are drawing a circle on a piece of paper. Okay, if you are drawing continuously drawing a circle with the center of the compass, what happens is at a point the paper will get toned out. Okay, that is called as repanning operation. Okay, it is the same process, is similar. Okay, similar to that of drawing drawing a circle with a compass. Okay, when it doesn't require a drill hole for its center. Okay, for finding its center, it doesn't require a drilled hole. It has a it has a compass like structure. Okay, compass and a needle like structure. So on the that particular needle will get in contact with the metal, and it is only for making a hole in flat surface. Okay, flat surface alone, it is possible for making a hole, right? So let us see the explanation. In tree panning, the cutting tool produces a hole by removing a disc-shaped piece. Okay, a disc-shaped piece, usually from flat plate. Okay, it is especially meant for making a hole in a flat plate without drilling operation. In case if you are supposed to make a hole of larger diameter, but you don't have a drill bit in your hand, what can be done is, if we have a tree panning tool, we can go with tree panning tool. Okay, a hole is produced without reducing all the material removed to chips. Okay, as in the case of drilling. In drilling operation, we will be converting the material into chips. Okay, but in this particular operation, only the external diameter will be removed, and the blank will stay as blank itself. Okay, it won't get converted into chip, right? Such drills are used in deep hole drilling machine for making large hole shafts, long machine tool, and spindles, etc. They have given some what applications also where we are using this particular pre-panning operation. The options has been given. I mean, the applications has been given. So the option B is the right answer for producing a large hole without drilling. Okay, so with this we have come to the end of this particular session. Thank you for your patient listening, and we'll meet up again for another session of manufacturing engineering. Okay, thank you all. Thank you so much.